In this demo, we'll see how we can have compiler running on Ramanujan. So the idea is that if there is a big amount of compilation that needs to be done, the compilation can be sharded, and shards of compilation can be done by devices running on Ramanujan. So for example, here I have a compiler which is running on the devices on Ramanujan. So so if I talk about this particular C file, so in this we are adding up numbers from 0 to 9. And what will happen is that for this example, uh, uh, the compiler will return back assembly code, and then we can get the assembler to assemble the assembly code into an executable. So assembly code has come back from the device, and it got assembled, and the executable was ran. It gave 45, which makes sense that we are adding 0 to 9. If I would change this example to 15, we would be adding from 0 to 14, and it should give 105. Yeah, we got 105. Another example where we are not having a for loop, but we have an if else. So for this, I have x, which is 5. X is less than 10, so technically it will increment x and it should return 6. Yeah, and if I would change this, I make it 5, then technically this branch should fire and it should return 4. Yeah, it returned 4. So this is just an example on how we can use idle compute power to help on solving shards of compute heavy problem. In future, we can have things like computational fluid dynamics also running on Ramanujan. Right now, we have successfully ran Phi 3 inference on Ramanujan. So this is just a demonstration how we can use the idle power to power any scientific computing. This project is open for collaboration. This is an MIT open source license project. Um, Thank you.